warahmatullahi wabarakatuh to our lecturer. My name is Farah Shuhada Binti Hassan. Our group will present about energy saving, efficient or management of solar energy technology. This is my group member, Mohamad Amri, Mohamad Zafri, Mohamad Najibbuddin, Mohamad Danial, Roziatul, Nisha, dan Alia Shazwani. This is our agenda of our project, introduction of solar energy, description, implementation, technical, impact solar on building performance, building of implements, and conclusion. Next.
Okay, Assalamualaikum to my doctor. My name is Nisha Binti Mazelan. In today's, I want to explain our project energy saving of solar energy technology. So first, I want to explain the introduction. The introduction of solar energy. The energy obtained by capturing heat and light from the sun. Energy from the sun is referred to as solar energy. Solar energy adalah tenaga yang diperolehi untuk menangkap haba dan cahaya dari matahari. Tenaga ini juga daripada matahari yang disebut sebagai solar energy. Solar technology divide by two category. First, active solar and passive solar. Active solar ni adalah teknik penggunaan yang menggunakan sistem photovoltaik. Ini juga untuk pemanasan solar energy untuk menangkap haba. Active solar juga digunakan secara langsung dari aktiviti seperti pengeringan pakaian ataupun pemanasan udara. Passive solar. Passive solar adalah teknik yang mengarahkan cahaya matahari itu kepada bangunan. Pemilihan bahan dengan jenis haba yang baik atau sifat penyebaran cahaya dan juga merancang ruang yang mengedar udara secara semula jadi. Next, solar energy juga boleh diubah menjadi bentuk lain. Solar energy terdapat 3 primary teknologi, iaitu yang menggunakan haba daripada matahari, iaitu tenaga terma untuk mendorong turbin elektrik berskala utility dan juga sistem pemanasan yang menunjukkan solar SHC yang mengumpulkan tenaga terma untuk menyediakan pemanasan atau penyejukan panas dan udara. Next point, saya serahkan kepada ahli grup saya untuk explain.
Okay, next is description of solar energy technology. Solar energy is a clean, affordable, renewable electricity source that can be used in almost everywhere in the global. Anywhere sun touch the earth's surface. And since sunlight is a source of the solar energy, it constitutes infinity power supply. Technology of renewable energy creates by power of endless resource. Solar energy is the sunlight that may produce heat, cause chemical process, or produce electricity. And solar technology may utilize the energy in a few ways, which is first, power generation, second, lighting, third, comfortable indoor environments, household, commercial, and lastly, industrial water system. Next.
I would like to share about implementation of the technology that we have choose, which is solar. The amount of sunlight that strikes the Earth's surface in an hour and a half is enough to power the entire world of a year. Solar technologies use photovoltaic panel or mirror to concentrate solar radiation to convert sunlight into electrical energy. This energy can be converted into electricity or stored in batteries or thermal storage. There are 5 steps how solar panel work. Step 1. Sunlight activates the panel. Panel are on the rooftop. Solar cell, commonly known as photovoltaic cell, absorb daylight sunlight. Step 2. The cell produces electrical current. When one layer is charged positively and the other negatively charged, an electric field is created. When sunlight reaches a solar photovoltaic cell it energizes and creates electrical flow. Step 3. The electrical energy is converted. The device known as an inverter can quickly convert DC current to AC electrical. This inverter installed in current solar system as a single inverter. Step 4. The converted electricity power at home. It routed through your electrical grid to power your appliances around your home. It operates in the same way that your electrical power supplier generates. Step 5. A net meter measure usage. A meter is used to measure power flow. Your utilizer often credit you for any excess electricity you send back to the grid. This is called net metering. Thank you.
Okay, next I will present for some technical highlights that are important for the solar energy technology. The first is accelerated deployment of renewable combined with deep electrification and increased energy efficiency can achieve over 90% of the energy related carbon dioxide emission reduction needed by 2050. Among all low carbon technology options, rapid deployment of solar PV alone can result in considerable emission reduction of 4.9 gigatons of carbon dioxide by 2050, contributing to 21% of the total emission mitigation potential in the energy sector. Second is achieving the Paris climate goals will require significant acceleration across a range of sectors and technologies. Solar PV will overtake wind power as the second largest power generating source by 2050, paving the global electrical sector path by 2050. Solar PV will have developed a quarter of world total electricity need 25% and will be significant generation source. Next. The third is at the regional level, Asia is expected to drive the wave of solar PV capacity installation, being the world leaders in solar PV energy. Asia, mainly China, will continue to dominate the solar PV power in terms of total installed capacity, with a share of more than 50% by 2050, followed by North America and Europe. And last, taking advantage of fast-growing solar PV capacity across the globe, several research projects and prototypes are ongoing to stimulate future market growth by exploring innovative solar technologies at the application level. Building integrated photovoltaic VIPP solar panels are one example. VIPP solutions provide various benefits, including multifunctionality. They can be supplied to a range of surface, cost efficiency, saving on roofing material, labor construction, refurbishing and maintenance expense, versatility and design flexibility in size, shape and color. Okay, next.
Yes, my name is Mohamad Jifferi, and I will present about the impact of technology of solar on building performance. Okay, as we know that solar energy technology building can save anywhere from 30 to 40% on their energy usage by employing the latest technologies. It also becomes a net zero energy building owners when generating more energy than you utilize. In no uncertain term, solar power building with the right usage of technology are more efficient in energy use. There are some advantages of using solar power in buildings, such as the first is limitless resource, which is solar power is renewable and is applied when second, low environmental impact. Solar technology can cause less environmental pollution depending on the magnitude of the system installed, from scattered rooftop PV arrays to huge utilities. Third, energy independence. It makes energy independent from building and places less demand on natural energy source. And fourth, multi-purpose. It can be utilized in several ways and for several applications. And the fifth, ability for addition, can easily include PV system by being modular. And sixth, portable, can be transported easily. And the last one is post installation and zero. Once the infrastructure is installed, there is no expense except changing inverter and batteries.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Najibbuddin bin Abdullah. I will explain about building with implementation and case study. Next. So, the building that we choose is Green Energy Office Building that stayed at Bandar Baru, Bangi. The geo building exemplifies integrated design ideas with active and passive energy system interlaced throughout the structure and numerous architectural features serving as energy system. This helped to reduce the building's additional expenditures. Throughout the design phase, modern computer design technologies were employed. It was designed based on concepts that emphasize green technological innovation to reduce energy demand load, efficient use of fossil fuels while considering environmental concern, and the use of renewable energy with jeopardized user comfort and safety. Building with implementation and case study. The first one, the structure is lighted mostly by natural light, with artificial lighting used only when it is extremely dark or cloudy. So this building use natural light, that is sunlight, and also artificial lighting when it is extremely dark or cloudy. So the building has extensive energy saving measure in place to decrease the demand for power to a bare minimum while yet providing a suitable temperature and humidity as well as enough lighting. The second one, the structure includes a BIPV building incorporated photovoltaic system that is structurally and aesthetically integrated into the structure. BIPV system may save money on materials and electricity, decrease pollution, and improve a building's aesthetic appeal. In the building at Ethereum, there is built-in solar photovoltaic. The solar system is generate clean and renewable electricity and provide daylight into the atrium, since this building use natural light.
My name is Danial, and today I will present the last part of our project, its conclusion. Okay, next. Next slide. Okay, the first is a dot solar system technology that's been described to limit the losses starting with solar cell building and incorporating principle. Solar cell efficiency and loss causes. Various varieties of solar cell from discovery to current technical development and future trend have also been covered here. Also highlighted were the solar energy inverter system and the important component that guarantee effective operation. Okay, next. The future trend is optimistically bright for solar energy application based on the emerging record achieved in solar cell technology in the recent few decades. In the very near future, solar energy will certainly be transformed in ongoing technology introduced into solar cell from niche to mainstream. The increased cost of fossil fuel and climate change awareness are other variables that are catalysts for altering this renewable energy supply. Okay, that's all for us.